question asks us to rationalize why trichloroacetic acid is a much stronger acid than acetic acid. The pKa difference is about 4 pKa units. pKa is a logarithmic scale. That means trichloroacetic acid is about 10,000 times stronger of an acid than acetic acid is. Comparing the two, they're both carboxylic acids. They have the same functional group, so that's not the difference. The difference is the presence of the 3 chlorines in the trichloroacetic acid. Why does that make it much stronger than acetic acid? Well, chlorine is more electronegative, so it's pulling electron density towards itself and away from others. Specifically, it's pulling electron density away from the acidic proton. By pulling electron density away from the acidic proton, we put less electron density around this hydrogen. That makes it have less electron density, that makes it more electrophilic. That means the partial positive charge on this hydrogen is a larger partial positive charge than the partial positive charge on acetic acid. They're both acidic protons. Trichloroacetic acid just has less electron density than acetic acid due to the inductive effect of the 3 chlorine atoms in trichloroacetic acid. For this reason, the proton is more acidic, and trichloroacetic acid is a much stronger acid than acetic acid.